Hi everyone. We have finished up our work over the last few days, week and a half or so, talking about angle relationships and parallel lines and finding missing pieces and parts. So I thought I would take today and I would walk through a couple of the problems from your homework that I noticed as I was looking over them. Some people were having struggles with. And then I want to walk us through some practice problems. So I'm going to highly recommend that if you haven't taken the time yet to print this PDF out, this worksheet out that I've attached to the video, that you guys should do that and work through these problems with me. And then on Wednesday, you're going to be getting a checkup over these similar type problems that you'll be turning in for a grade. So if you want to stop the video right now, take a minute, get these problems in front of you so you can follow along as I work through them and talk through them, that would be great. Also, I still have posted in Classroom the vocabulary lesson that covers this information. You could use that as well to review and study. So let's get started. I wanted to look first at problem 19. This was homework from 912. And in this problem, it was called an additional challenge. I like it because it involves many of the properties as well as some different algebra situations where you had to do some solving. So I'm just going to kind of walk through each one of these. You may have done just fine with this, and if you did, you can fast forward on to the next problem. But if you didn't, then you'll get some help here. So looking at A, when I look over here at A, I see that I've got three angles in a triangle, and the one thing I know from the angle sum theorem is that these three angles together, this angle that has a measure of x, the angle that has a measure of 2x, and the angle that has a measure of 30, those three angles have to total 180. This gives us a pretty straightforward equation that we can solve to find our value of x. And in each of these, we only had to, it said, use what you know about triangles and angle relationships to find the missing angles in the triangles below. I'm going to focus first and foremost on just finding x. I'm sorry, talking and writing at the same time. You guys missed this about me, didn't you? So 150 divided by 3, we get x equals 50. So if knowing that x is 50, that means that this angle measure right here is 50, this angle measure right here is 100. All right, so that would be applying that idea of having the three angles add up to 180. You can do the same thing for part B, but part B's equation is a little more complex simply because of this right here. So our equation would be x plus 10 plus x plus 90. And I will tell you that sometimes we see that 90 drawn like this, indicating that that's a right angle. We know that those together add up to 180. And again, we could go through, we'd have 2x plus 100 equals 180, and I think from there you guys would be fine solving. So that would cover that property. I think the challenge part of this problem really came in the next part for C and D. In looking at C, I have to find x over here. Let's make this green. I have to find x over here, but I also have to find y down here. And so there's different pieces that come into play here. I'm going to start with x. What I notice is that this angle right here is 92, and it makes a straight angle with this one right here. So I know that if this is 92 right here, that the other angle has to be 180 minus 92. So 180 minus 92, that would be 88. And then at this point, we've got that angle as 88 right in here. We've got the 36. And that makes our x right here equal to 56. So that was the first catch. It's just trying to figure out how we can find our missing pieces and parts. So once you have the 56, Now we're going to move on to find y. And I can, I'm going to focus in on, this is a little trickier to see. Y is part of this big red triangle here. So what I know about this is I know that 36, this is the red triangle, plus 116, plus this whole thing right here, plus 15 plus y has to equal 180. Again, this is a situation that now that I know that, if you guys can see that, that was the hardest part of this problem, is just seeing that. So you just add up the numbers, subtract from 180, and you get your value for y, which I believe, looking at the answer key, you should have gotten y as 13. Moving on to D, it's a similar type situation. You've got some overlapping triangles here. And in that sense, you have to recognize that you've got a right angle here. And if we look at this blue triangle that I'm outlining in blue, in that triangle, we know that 54 plus 90 plus x equals 180. And once we find x, we can find this piece over here. And then you still have to do some unwrapping. So down here, oh no, I take it back. I would probably just see this as 105, and that makes this angle 105, because this is that idea of a vertical angle. And once you have the 105 there, and if we have, I'm going to change colors into red, and if we have our value from x in the blue triangle, then we can just subtract those from 180. So we would have those values together equaling 180 and then subtracting to find y. So that was the challenge of problem 19, was just looking for the overlaps and how to pull some of those triangles apart. I also wanted to look at 34. This was from last Wednesday. It's the homework that was due today. I was seeing some relationships written wrong, so I wanted to touch base on that. For example, in A, this situation here, this is a straight angle right here, which means that the 2x plus 3 plus 132 has to total up to 180. Or you might have started out by taking the 180 and subtracting the 132 and then saying that 2x plus 3 is equal to 48 and solving from there. So that would be, this is a straight angle. Another way of referring to this, which you'll hear when you get into geometry, is as a linear pair. All right, and then part B brings into play this idea of remote interior angles. But again, I don't know if you noticed, but you've got a straight angle right here. So we can use that same idea of subtracting 131 from 180. So D has to equal 49. You've got this right here going on, which you have to recognize as a 90-degree angle, and then you simply subtract the 90 and the 49 from 180 to get E. And then in this last one, this one involves the fact that the measure of angle F, our exterior angle, is going to be equal to the sum of the remote interior angles. And the remote interior angles are those angles that are not connected to or adjacent to angle F. So the measure of angle F then would equal 43, and I sincerely hope I just added those correctly. Yep, 43 degrees. All right, so those were a couple of the homework problems. Now I'm going to scroll down. I've attached some review problems, and again, these are going to be similar to the checkout problems that you have coming for a grade on Wednesday. So if you want, you could go through these 4 on your own first. You could stop the video right here and go through and solve them, and then watch and see if you get the right answer. And that would be your way of practicing, or you can just follow along and work along with me. For this first problem, Again, we've got this idea that it is a straight angle, and a straight angle adds up, a linear pair adds up to 180. It's a straight angle. They are supplementary. And that means that 68 plus 5x plus 12 has to equal 180, and then I can start the solving process. So I would have 5x combining like terms plus 80 equals 180, subtract 80. I get 5x equals 100, x is 20. That is what I'm looking for. I can see then that 5 times 20 plus 12 is 112, and 112 plus 68 adds up to 180, so it does check. Looking at the next problem, this involves our vocabulary from the first lesson. So we're trying to find x. X is an alternate, 7x plus 3, this angle right here, is alternate interior angle to this angle right here. And we know, we can see these are parallel lines. We see that because they have the markings right here that show us they're parallel. And alternate interior angles are equal in measure. So then we could simply say 7x plus 3 equals 52. So 7x equals 49, which means x is 7. So 7 times 7 plus 3, 49, plus 3 is indeed 52. And so it checks, it works. That is our value for 7. So again, alternate interior angles are equal in measure. Corresponding, we could have said that knowing that 128 is a straight angle or a linear pair with the one I just pointed an arrow to, that one would be 52. And then we have corresponding angles that are also equal in measure. So that's our parallel lines. This one, number 3, is about our exterior angle. So an exterior angle equals the sum of the remote interior angles. So I know, based on that 117 is equal to the sum of 8x plus 57, and I know they're remote, they're removed from the 117, they are not connected to or adjacent to 117. Go through, subtract 57 from both sides. I get 60 equals 8x, divide by 8, that is 7.5. Equals x. All right, and we'll continue moving on. This last one has to do with our angle sum theorem, that the sum of the angles in a triangle equals 180. So I know that 30 plus 19x plus 3 plus, again, remembering that this is a right angle, and that equals 90, plus 90 equals 180. I'm going to put my like terms together. So I get 19x plus 123 equals 180. Do some subtraction. I get 19x equals 57, and x equals 3. All right, so that covers everything we have done up to this point. Again, Remember that you have the vocabulary that also has that information in it. You could go back over any of the lessons that we've covered. You will have problems similar to this. I would expect to see the same kind of work that you're seeing on this paper to receive full credit on the checkup that you'll be given on Wednesday.